Welcome back to another video by Adeptus Academy. Imagine a world where light and electricity work together, powering the technology that surrounds us. These two forces combine to create the backbone of our digital age. From smartphones to the internet, light and electricity are the invisible partners enabling our modern lifestyles. This is the magic of optoelectronics, where science and engineering harness the power of both light and electricity. You experience optoelectronics every day, watching movies, streaming videos, or connecting with loved ones. Fiber optic cables send data at the speed of light, transforming global communication. Get ready to discover how light and electricity are creating a brighter, more connected world. At its core, optoelectronics is about converting electrical energy into light and vice versa. This fascinating field bridges the gap between electronics and photonics, allowing us to manipulate both electrons and photons to create groundbreaking technology. Devices like LEDs turn electricity into light, illuminating our homes, screens, and cities with vibrant colors and efficient energy use. These tiny components are found everywhere, from the displays on our smartphones to the headlights of modern cars. Meanwhile, sensors in cameras and other devices convert incoming light back into electrical signals, enabling us to capture images, scan barcodes, and even unlock our phones with facial recognition. This remarkable exchange happens inside semiconductors, special materials that let us precisely control the flow of electricity and the behavior of light. Semiconductors are the foundation of all modern optoelectronic devices. The secret lies in the band gap, an energy hurdle that electrons must jump to emit or absorb photons. When electrons cross this gap, they release or capture light, making optoelectronic magic possible. The size of the band gap determines the color, or wavelength, of light produced or detected. By carefully choosing and engineering materials, we can create devices that work across the entire spectrum, from deep infrared to brilliant blue and beyond. By engineering semiconductors, we create devices that emit or sense specific colors, from invisible infrared used in night vision and remote controls, to the vibrant displays in our TVs and monitors. This simple yet powerful interaction between light and matter powers everything from ultra-fast fiber optic communication to advanced medical imaging, revolutionizing how we connect and diagnose. Optoelectronics harnesses these principles to build technologies once thought impossible, driving innovation in fields like quantum computing, renewable energy, and beyond. It's a dance of photons and electrons that shapes our digital world, enabling faster data, sharper images, and smarter devices. Understanding this process reveals how we communicate, see, and innovate at the speed of light, unlocking a future limited only by our imagination. The magic of optoelectronics starts with the right materials. Silicon is the backbone of electronics and excels at detecting light, making it perfect for cameras and solar cells. But for creating light, we need compound semiconductors like gallium arsenide, which power LEDs and laser diodes. By mixing elements, engineers fine-tune materials to emit different colors and intensities. Indium phosphide is crucial for fiber optic communications, sending data across the globe. Specialized materials like nonlinear crystals and photocathodes enable fast light switches and ultra-sensitive detectors. The search for better materials drives optoelectronics forward, promising even more efficient and powerful devices. Every breakthrough in materials brings new possibilities for technology. Meet the stars of optoelectronics, devices that create, detect, and control light, powering the technology all around us. LEDs light up our screens and cities, offering brilliant colors and energy savings. Laser diodes deliver focused beams for fast internet, surgery, and data storage. Photodetectors act as electronic eyes, turning light into signals for cameras and sensors. Image sensors capture our world in stunning detail for photos and video. Light modulators encode data for fiber optic networks, enabling global communication. Together, these devices connect, illuminate, and transform our lives, quietly powering the modern world. LEDs have revolutionized lighting, using less energy, lasting longer, and making our world more sustainable. They power the brilliant screens on our phones, TVs, and computers, delivering vibrant colors and perfect blacks. OLED displays take it further, using microscopic LEDs for flexible, ultra-thin screens. Laser diodes, with their precise, coherent beams, enable everything from Blu-ray players to laser surgery. In manufacturing, lasers cut and weld with pinpoint accuracy. In medicine, they allow surgeons to operate with minimal damage and maximum precision. From barcode scanners to life-saving procedures, laser diodes are everywhere. The focused power of these tiny devices continues to transform industries. LEDs and lasers are lighting the way to a brighter, more efficient future. Photodetectors are the unsung heroes, translating light into electrical signals our devices can understand. Photodiodes sense everything from your TV remote signal to the ambient light for your phone's screen. In solar cells, they convert sunlight into clean energy for homes and businesses. Image sensors, packed with millions of photodetectors, capture every photo and video we take. These chips turn light into digital images, powering our cameras and webcams. In medicine, photodetectors enable advanced imaging and diagnostics. In astronomy, they reveal distant galaxies and the secrets of the universe. From daily convenience to scientific discovery, photodetectors connect us to the world of light. They are the essential link between what we see and what technology can do. Optoelectronics powers the technologies that define our era, especially the global internet. Laser diodes, modulators, and photodetectors work together to send data as light pulses through fiber optic cables, connecting continents in milliseconds. This system delivers massive bandwidth, reliability, and speed, far beyond what copper wires could achieve. Without these components, our high-speed, data-rich world wouldn't exist. In medicine, optoelectronics enables minimally invasive procedures, from endoscopy to real-time oxygen monitoring with simple finger clips. Lasers and fiber optics give doctors new ways to see and treat inside the body. In industry, lasers cut, weld, and 3D print with unmatched precision. Consumer electronics, from screens to cameras, showcase optoelectronic engineering. Even self-driving cars rely on laser-based LiDAR to see the world in 3D. Optoelectronics is the foundation for innovation across every field. The next leap in optoelectronics is silicon photonics, integrating light-based components directly onto silicon chips. Traditionally, optical and electronic parts were made separately, slowing progress and raising costs. Silicon photonics aims to put lasers, modulators, and detectors on the same chip as electronic circuits. This creates photonic integrated circuits, or PICs, which manage both electrons and photons on a single chip. The result? Smaller, faster, and more energy-efficient devices, mass-produced like computer chips. PICs promise ultra-fast, low-power connections for data centers and AI, breaking through today's data bottlenecks. They'll also enable new sensors for medicine, the environment, and autonomous vehicles. By bringing the speed of light onto the chip, silicon photonics is set to spark a new technological revolution. The future of computing and communication is being built with light. Optoelectronics is the science behind our illuminated, connected world. It transforms the partnership of light and electricity into technologies that power communication, entertainment, and medicine. Every photo, video call, and internet search is made possible by decades of innovation in this field. As silicon photonics and integrated circuits evolve, we're entering an era of even faster, smaller, and smarter devices. Optoelectronics is the foundation for breakthroughs in AI, quantum computing, and personalized healthcare. The journey of harnessing light is a testament to human ingenuity and our drive to build a better world. As we refine materials and master integration, the possibilities are limitless. The future will be brighter and powered by light.